Here we go. In your Google machine, you will find this solar system model. I have created a spreadsheet that we will use today to ascertain sizes for our model. Sizes like diameters and distances. Does that make sense? From reality, we're going to shrink the solar system down for a scale model. Got it? I think I already warned you about this. Here we go. You do not have access to this spreadsheet because I don't want you marking it up and messing it up. Make sense? So you're going to go File, make a copy. By the way, if you don't pay attention, you will get behind, and then you'll be like, how do we do this? I'm lost. And it's because you weren't paying attention. Stay with me, okay? So make a copy. Right before where it says copy, just put your name. Okay? Whatever your name is, that is now your copy of this document. So you can mark it up however you see fit. Make the copy. Oh my goodness. There we go. Screencastify getting in the way. All right. All right, good. Here we go. I want, first of all of our diameters and distances are in miles. Do you think that's super awesome for the scientific community? No. No, we're going to want to go ahead and convert that to metric. So we're going to go miles to kilometers. I have put for you right here 1.6. That is the conversion factor. If you are tapping on your table, holy mackerel, I don't know how the mackerel got holy. Maybe it was swimming in some holy water, but holy mackerel. Okay, so it's a fish. A mackerel is a...
Holy cow.
No, not a... That's a whole different story. How the cow got holy, I'm not sure. Maybe it fell into a pond of... I don't know. Shh. All right. So how do we use this? Guys, if you've never done this before, you might actually find this useful. You might actually go, oh, this is kind of cool. We're basically learning two things today. A little bit of science and a little bit of computer science. Yeah, okay. So here we go. Check it out. I am going to go ahead with yours too, light up that box for where it says sun on the left and above it says diameter in kilometers. Highlight that box, and I'm going to tell the computer program that I'm doing math. So I'm going to hit equals. Go ahead and hit equals. And because I've been using the same program in basically the same way all day today, you're my last class, it already kind of knows what I'm going to do. Or at least it thinks it knows what I'm going to do. It's been making mistakes, so I've got to be diligent to catch its mistakes. What do I mean by that? Well, it thinks that I want to take B3, I feel like we're playing Battleship, which is the diameter in miles of the sun. I do. And it thinks I want to take that and multiply it by the conversion factor to get it in kilometers. I do. So if I'm fine with its suggested math, all I have to do is hit enter. Now, if it didn't make the suggestion, then you would just hit equals, and you would click on the boxes that you want to multiply. You'd hit Shift 8, which is the asterisk, which is the multiplication symbol, right? And then you'd click on the other box. Here, let me demonstrate. So if it didn't automate it for you, you would go equals sign, and I would click right on that box. I would go Shift 8, and then I would click on this box, and then hit enter. Does that make sense? Instead of clicking on the box, you could type in B3 times C2. You could do that. Enter. Now, once you get the first box in, go to the next one down, hit equals, and you will see it is once again making a suggestion. Verify that that's what you want to have happen. That is what I want to have happen. Hit enter.
It's not coming up for me.
So you'll have to manually input it. Let me show you again. If I go to the next box down, I'm going to say equals.
Oh, I forgot to.
Then I'm going to click
That's why.
on the box I want to multiply first. Shift 8 times the other box I want to multiply by, and hit enter. But yeah, you got to remember to hit equals first. Equals, check it, enter, down. Equal, check it, enter, down. Equal, check it, enter, down. All the way to the bottom.
I wonder what the distance is.
We're not there yet, dude. All right, dude. All right, now we are done with our diameters. We're still at full size, but we've converted to a unit that is internationally recognized. Does that make sense?
What?
We are now moving over to distance to sun. Got it?
Yeah.
Okay. So equals. Hey, computer, I want to do math. I'm hitting the equals button. Look at me. Right? And, oh, look, it doesn't make a suggestion this time. I like that, okay? So what we're going to do, if we want the distance to the sun from the thingamajig in kilometers, okay, you're going to take the distance from the sun to the sun. What's the distance from the sun to the sun? It'd be 0, wouldn't it? So let's instead of having NA, let's actually go ahead and put a 0 there. Go ahead. Distance to sun in miles, go ahead and put a 0 for sun to sun. Now, distance to sun kilometers, hit equals. Now you're going to click on D3, which is distance to sun in miles, times Shift 8, and then you're going to click on the conversion factor to go from miles to kilometers. And hit enter. And you should get 0. Got it? Good. Moving down to the next one. Equals. Verify that it's got highlighted the boxes you want. Distance to sun in miles times the conversion factor. Good. And then continue on down. Every time, take a second to make sure it's highlighting the right boxes. Peer tutor, could you close that door for me, please? All right. Everybody there? Okay, now listen carefully. All we have done thus far is take the size of the sun in one unit and describe the exact same size of the sun and the planets and everything in a different unit. We haven't actually scaled anything down yet. Where is my globe? There it is. Thank you. So we want to scale a whole solar system down. I understand that this is a model of planet Earth, but through years of experience with this project, I want to use this as the sun in our model. The reason for that is if I went much bigger, let's say I took a big beach ball to be the sun, it would make the other planets more tangible. It'd be nice sizes to handle and stuff, but the distances would be insane. When we actually do this outside, you're going to see that it's pretty extreme already. Now, if I went any smaller than this, well, then the planet models would be so small they wouldn't be easy to handle. So this is kind of a happy medium. It's not perfect because making a scale model of the solar system is nuts, but we're going to do it anyway, okay? So this is going to be our sun. The first thing when you make a scale model of anything Obviously, you need measurements of the real world thing, yes? So we have our measurements of the actual solar system for the diameters and the distances. Then you need to pick one of those and set the scale. To set the scale, you're going to pick one object or one distance, and you're going to say, what do I want it to be on my model? So I've already done that, haven't I? I said, I want this to be the sun. Okay, what's next? I take a ruler, and I measure the diameter, and I get 28 centimeters. This has a diameter of 28 centimeters. Everybody follow my logic so far? Okay. I need a conversion factor. A number that I can multiply by all of those to get to the size of our model pieces. Does that make sense? You'll see. So I'm going to take 28 centimeters and I'm going to divide it by the metric diameter of the sun. But can I divide centimeters by kilometers? No, it's not going to work out right. Okay? So I need this in kilometers. So remember back to the beginning of the year when we did metric system conversions. It's pretty easy. Right here, I've got 28 centimeters written down. And what I did, you can see I moved the decimal place 5 places to the left to get kilometers. Why 5? Well, I'm at centimeters. Move it 2 to the left to get to meters, and 3 more to get to kilometers. Does that make sense? So 0.00028 kilometers is equal to 28 centimeters. Yes? Or just trust me. That's okay. Now I take 0.00028 kilometers divided by the actual size diameter of the sun, 1.335744 million kilometers. Yeah. And I get a conversion factor. I wrote it in scientific notation because I thought I was being smart this morning. It worked out to I'm rounding, 2.1 times 10 to the negative 10th. I put it in the sheet for it to do math with, and it went, nope. It spat it out. It said, put in a real number, thank you. So I had to convert back out of scientific notation. You've done this before, right? You guys remember? Okay. Which means I have to move to the left 10 places because it's a negative. Make sense? That is how I got to this. Okay? That is how I got right here. I have 0.9021. That is kilometers to kilometers. Good grief. Do I want to talk about how big our model pieces need to be in kilometers? Would I measure this little beach ball in kilometers? No. So I got a conversion factor to bring the solar system down to our model size, but I need to tweak our conversion factor to make it what I want it to be. I want our model pieces of our planets and the sun to be in centimeters. Do you see right here? All the way to the right. Model diameters, I want those in centimeters. So I'm going to take my 9 zeros, right? And I'm going to say, wait, I want to go back all the way to centimeters. So how many did I have to move it to go from centimeters to kilometers? 5, right? Now I need to go back the opposite direction. So I'm going to have 4 zeros left. So let's go ahead and put in right here, model diameter, 0.123421. That is going to be that's going to do all the work for us. So a review. This conversion factor takes care of 2 things. It shrinks the solar system down to our size, and it puts us into a measurement unit that makes sense for our models. What did I say? 4. 0.4 and then 21. So 0.000021. Stick that up there. Okay. Everybody there? Everybody following along? Fantastic. Next thing. So we're just going to stay here in this column. Model diameter. If we did the math right, how big did I say this was?
28 centimeters.
28 centimeters. So if we did the math right, it's going to tell us 28 centimeters. Here we go. Equals. We want the diameter in kilometers times our fancy, specialized, customized conversion factor. And then we're going to hit enter. Does it say 28?
Yep.
Outstanding. We did it right.
Wait, what convert? Wait.
The conversion factor we just put in right here.
Oh, thank you.
Yep. So diameter of sun in kilometers in real life times our modified conversion factor, which is going to...
Hashtag value.
So you put something in wrong. Let me take a look. Moving on. Actually, we're not moving on yet. Aren't we? We got to go down the column, yes? All right, so again, be careful. It's done this anomalous thing where it'll try to jump to the wrong box. All right, so make sure. So I'm going to verify. I hit equals. I'm verifying it's going to diameter in kilometers. Good. And then it's also wanting to multiply by our fancy conversion factor. Perfect. Every time I'm going to make sure it's going to the right boxes. Whoops. Move to the last. We are now at the last column. Okay? We again need to customize our conversion factor. Notice at the top it says model distance to sun. I want this in meters because that's the most appropriate, and you'll see why when we get to measuring these out. I want it in meters. So again, if we started with 9 and I want it to go not all the way to centimeters, I just want to go to meters, I'd go from kilometers to, what would this be? Hundredths place, right? And then so 1, 2, 3 back. So 9 minus 3 is 6. So we'd have point, okay? Point 1, 2, 3, 4, 5, 6, 2, 1 is going to be our custom conversion factor to go from the actual distances in kilometers to our model distances in meters. Okay? So once you have that there, 0.000000021. And then we're going to say, hey, equals. We want model distance to sun. This first row is of the sun. So it should, we have, oh, look, this is perfect. It is trying to grab back the diameter of this. I don't want it to have, we're doing distance. So you will have to click distance to sun. Oops, not in miles. No. Good grief, we need to delete that. Equals distance to sun in kilometers. Why does it matter? They're both 0. Well, because one will affect the formula, right? Wrong. All right, so we got the correct box times our new custom fancy conversion factor. Enter. And I should have 0 because from the sun to the sun is 0. But if we go to the next one and we hit enter, now it should properly drop back to Mercury's actual distance in kilometers from the sun times our fancy conversion factor. Hit enter, and that is correct. On our model, Mercury will be just over 12 meters from the sun.
Wait, what? Mercury, I got 0.
Well, you shouldn't have 0 for Mercury because Mercury is right here.
OMG, this is.
This is the sun. This is Mercury.
I thought we were still doing diameter. Oh my gosh.
Wait, we're doing distance to sun, right?
Yes.
Why is it a different column?
For the model. We're doing the model. Look over here. Model distance to sun. Actual distance to sun is here.
Wait, so we're doing E.
Yes, I was doing C still.
I was doing D. So E. Oh, that's all D. So E. So equals.
You got to look at the heading of the column, guys. Pay attention. And pay attention to what row you're in. If we're doing Mercury, you shouldn't be in the sun's row. All right, so now I should be able to go to the next one, which would be Venus, right? Hit equals. I want to go to Venus's actual distance from the sun in kilometers, which is right there, times our fancy conversion factor, and it will get me the right number. Once you're sure that you've got the formula in the next one should be automated. You're just going to double check that it's highlighting the correct boxes. Something's wrong there. Check that out. This is good. Guys, look. If you're going further from the sun, these numbers should be increasing. So I need to go back to this one and see what it did. It dropped back and took distance to sun in miles. Don't let it make that mistake. So I need to come here. I need to delete this. For whatever reason, the computer grabbed the wrong one. So I'm going to say equals, and I'm not, no, I need distance to sun in kilometers times our fancy conversion factor. Whoops, no.
31.23.
There we go.
I'm done.
There we go. Y'all are finishing up? Oh, look, it's trying to do it again. It's like, hey, you want? No, I don't want that.
It does that for like the rest of the time.
Okay, so make sure you're verifying that it's taking the right one. Remember that we've been messing with this spreadsheet all day, so it's no longer clean and fresh. So we've got to be very careful. And now it's back to good again.
Anything else you have to do after that?
And we are complete. So, I'll give you a minute, well, as many minutes as you need to finish that, clean that up. But I want to basically talk to you just for a second about what this means for our model. It means that if this is the sun, hold that. 12.1 meters away from the sun would be Mercury. How many feet in a meter? Just over 3. Okay. So I want to say 3 feet is 36 inches, right? And a meter is 39 inches, I want to say. So anyway, basically we're looking about 37 feet. Okay. That would put, if that's the sun there, Mercury would be at the wall. And it says right here, so here's the distance, Mercury to the sun. This is the size of the actual planet in our model. 0.1 centimeters. That is equal to 1 millimeter. Look at your fingernails. You've got the width of your fingernails. You've got the length of your fingernails. I want you to look at the thickness of your fingernails. That is approximately a millimeter. If you made something 1 millimeter roundish, would it be about the size of a grain of sand?
Yeah.
Depending on the sand, right? Medium coarseness sand would be about a millimeter. So I want you to imagine a grain of sand on the wall. Would you even see it?
Yeah. No.
No, because it's the same color as the wall pretty much, right? Sun to planet Mercury, that's the actual scale. That's real life scale. Just
From up here?
brought back down. Toss that. What do you mean from up here? I'm saying if we made a model of the solar system and this is the size of the sun, Mercury would be a grain of sand 37 feet away. Does that blow your mind a little bit? If that doesn't blow your mind, I will blow your mind when we go outside when the weather's better, and if it's not better within a couple of days, a couple of school days, we're just going to go out and brave the weather. We won't be out there long, okay? But we'll be able to show you that it's crazy. All right. Questions, comments, concerns? Who needs help with finishing up their spreadsheet? All right, I'm coming.